I've given literally hundreds of these talks, and it all started years ago when I really didn't know any climate scientists, and now starting with 1, then 2, then 10, now literally hundreds of climate scientists, atmospheric scientists, oceanographers, glaciologists have become my teachers and in many cases my friends, and even started inviting me along with them out in the field. I just came back from my 4th trip to the Greenland ice sheet this year as part of the Dark Snow Project, which is a science communication crowd-funded venture that was started by Dr. Jason Box, a glaciologist very well known at the Danish Geological Survey. And he called me about 4 years ago, and we had met each other a few times, and he said, would you like to go to Greenland? And I said, yes. And so since then we've been working on trying to experiment with different ways of getting these messages out into the media and getting people to understand who the scientists are and what they're telling us. This is just a little video from that first year. We went to a place in the center of the Greenland ice sheet where very few people go. It was kind of a pretty interesting introduction for me. I'm told we were the first team to ever go into that particular spot by helicopter. And it was, the word intense just doesn't even cover it. Greenland is spectacular, mind-bending, and unbelievable, and life-changing. I am also author of a video series called This Is Not Cool that appears on the Yale Climate Connections website, and that comes out monthly. You'll be seeing some of those tonight. There's a lot of people here. Okay. Thank you. Okay. Much better. Okay, so let's get started. Based on the evidence, 97% of climate scientists agree that human-caused climate change is happening now. But only 27% of Americans know this. That's the problem. That's what we're working on. And the scientists have been reaching out to communicators, and communicators have been reaching out to scientists. And we're gradually developing cadres of scientist communicators and communicator scientists who can get this message out, and it's starting to ripple out. We're starting to make some traction. But the overwhelming factor is that the Earth itself is probably speaking more loudly than any of our voices. Climate change, it's physics. I'm not going to, for this audience, go through the carbon dioxide acts like a blanket. I'm sure you've all heard that part of the talk. In a nutshell, climate science is this. There are gases that trap heat, heat-trapping gases. We're adding more of them to the atmosphere when we burn fossil fuels. We reason that if heat-trapping gases trap heat, that more heat-trapping gases will trap more heat, and heat makes things warmer. So that is climate science. That is the physics. And so we are looking at the energy that is coming in from the sun, which we can measure with satellites, and we are looking at the energy that is then re-radiated out from the Earth. We see that some of it is being held back. We can also measure that accurately. Not a theory, measurements, it's happening, it's real, and it is not small. The amount of energy that is being held back by our additional greenhouse gases is equivalent to approximately 400,000 Hiroshima-sized bombs per day, 365 days a year. It's a lot of energy. So that is starting to have an effect. Now I have climate denier types, climate science deniers that come at me regularly, and they tell me that there's no such thing as settled science. There's no such thing as settled science. Okay, this is a thermometer. Now you all probably learned in 5th grade how this works, right? there's a certain amount of a fluid in here, in the little bulb. This is the old-fashioned kind, it's not digital, right? And it's in a space, a known volume, and if we add heat to the fluid, it will do what? It expands, right? So it rises up the tube, and we read that as temperature, okay? That's a thermometer. Okay. This is a thermometer. It is a fluid of a known volume in a vessel of a known capacity, the oceans. And if we add heat to it, which we have literally tens of thousands of measurements that we are, it should expand. We should expect it to expand just like the fluid in the thermometer. Okay, in fact, of the heat that the Earth is trapping, about 93% of it goes into the ocean. So the ocean's a really good indicator of what's happening. Just about all of the heat goes into the ocean. This little orange line down here, that is everything. That is forests, soils, icebergs, everything that you can imagine. Mountains, cities, agriculture, 93% goes into the ocean. So we would expect to see the ocean to respond to all this additional heat. And in fact, here is sea level over the last 2,000 years. And you can see this spike in the last 150 years or so. That's us. That's sea level rise. That is the heat going into the fluid and expanding it. Okay, most of the sea level rise that we've seen so far comes from this expansion factor, okay? But there's another factor that's starting to come on strong, and that is we're starting to melt ice at the ice caps. Here's a little bit closer look. This is the sea level measure from satellites, which is the gold standard, and you can go to this online. Just Google Colorado sea level satellite, and you can find this graph instantly. It's updated regularly, very frequently, and if somebody tells you that the Earth is not warming, or it's cooling, or it's slowing down warming, or anything like that, you show them this graph, and you can explain to them that unless everything we know about physics for the last 300 years is wrong, there's no way you get this graph in the absence of a warming planet. This is what's happening, okay? So, in fact, global surface temperature, this is the most recent graph from NASA. Got this just a few days ago. Very interesting pop in the last year. We've had an El Nino event, really a super El Nino event. You might have heard about it in 2015 and the first part of this year, which has, you can see the last one right here, 1998. See that big spike there? That was the last big El Nino event, and we had a few smaller ones in here, but this one is a super El Nino, and so now we're bumping up to a whole new level. And this spike has very conservative, sober scientists using words like shocking, frightening, astounding. We've bumped up into a whole new regimen of planetary warming. And we hope that as the corresponding La Nina event begins to come on, which is happening now, that we will see a little bit of that this spike will ease off just a little bit and will continue to move up, but a little more slowly, we hope. So the sea level rise is showing up due to the loss of ice. Just to show you how serious that is, this is Admiral David Titley, chief oceanographer, or former chief oceanographer for the US Navy, who will be speaking at CMU on the 20th or 21st of this month. So I recommend running up there if you get the chance. Here's him talking about how seriously he and the US Navy are taking this sea level rise.
And these glaciers are starting to fall apart much faster than anybody, even 2 years ago, thought they were going to do there. So this is going to be a huge issue. And potentially, we can see the seas come somewhere between 3 and 6 feet in the 21st century. 8 inches in the 20th century, 3 to 6 feet in the 21st century.
Okay, so 3 to 6 feet in this century. That, you can consider that kind of the conservative, mainstream estimate. That's the one that the U.S. Navy feels comfortable with. It's kind of a big deal for them. One congressman once asked Admiral Titley, why are you so concerned about sea level rise? Because all your boats float, right? And Admiral Titley had to explain that the boats do float, the bases not so much. So that's a problem. That's a problem. So anyway, this whole idea of sea level rise is so serious that a lot of people don't understand, because they don't understand the track that we're on here. I've been talking to a number of paleoscientists. Anytime you see the word paleo, it means something that happened a long time ago. And these are people that look at evidence of things that happened in the past when the atmosphere, through natural processes, was similar to what we've done to it now. Okay? And they're telling us a very, very concerning story about what our current level of greenhouse gases means for sea level rise. So I'm going to show you one of the videos I've made. I've made a number of videos on that, but this one I think is particularly powerful and gets the point across. Here we go. And we did a sound check, so hopefully everything should work.
There are some lessons from the past that make this particularly worrisome. One is a trace of sea level through time through the last deglaciation. So sea level was 120 meters lower during the last ice age. When it rose to form the interglacial world that we live in today, it didn't just rise in a smooth way, but it seemed to go in pulses. And in particular, there was this one interval called meltwater pulse 1A, which was a huge amount of water, a very large change in sea level in a very short time, and glaciologists aren't even sure where this water came from.
The big tipping point is the ice sheet stability. The danger is that we could get enough warming and begin to start the melting processes on the West Antarctic ice sheet and the Greenland ice sheet, and cause those to become unstable and get a situation where it's out of our control. I think we're getting very close to that.
Another important story today, scientists warn that a large part of Antarctica is melting and cannot be stopped.
The area shown here in red, scientists say further degradation is almost certainly unstoppable. They say global warming is accelerating the pace of disintegration.
We are heading toward a particular sector of West Antarctica draining into the Amazon Sea. This sector is drained by 6 glaciers. The biggest ones are Pine Island Glacier and Thwaites Glacier.
We passed the point of no return in this sector, and at this point, we'll say it's just a matter of time before these glaciers completely disappear to sea. We are seeing in this sector retreat rates that we don't see anywhere else on Earth. There's probably nothing that can be done to stop this. It can be slowed down, but it's kind of difficult at this point to see any physical process that would stop it. This system is evolving very fast, and it's progressing exactly as you would expect if it was about to collapse to sea.
In this region of Antarctica, glaciers are anchored at the sea bottom to a point scientists call the grounding line. As more warm ocean water eats away at the underside of the ice, that grounding line has been steadily retreating, allowing even more warm waters to penetrate deep under the glacier. Multiple studies of this area show that the retreat of the grounding line has been accelerating in recent decades.
The ice sits on a high spot, and when it moves off of that high spot, it does not do so slowly and gradually, it jumps. This is a model. We did this with 3 different models in 3 different ways. Say if sea level is rising, I'm going to eventually float this ice, which is flowing from left to right, but on a perfectly smooth bed, and that is what sea level rise or melting at the edge would do to the ice. It would thin and it would float, and it's not very exciting. Now, if we do the same thing here, except I put in a little topography, what would happen is that nothing, it's sitting here, it's sitting here, it's sitting here, it's sitting here, watch. All the different classes of models that we've got do the same thing. This is where it is today. Forcing gets almost no response, forcing gets almost no response, forcing gets a huge response.
The new research shows no further obstructions between the current grounding line and the deep interior of West Antarctica.
As the glaciers retreat, they will follow these deep valleys. There is no mountain or big hill along the way that could act as a barrier to hold these glaciers back. The glaciers speed up, the grounding line retreat, the deep valleys that are sloping inland all reinforce each other to make the retreat of ice in this part of Antarctica unstoppable. And we think that this is what is happening right now.
The last time that ice sheets disintegrated was 14,000 years ago. Sea level went up 20 meters in 400 years. So that's 1 meter every 20 years.
NASA's lead polar ice researcher said, quote, "This is really happening. There's nothing to stop it now."
It in fact looks like this weak underbelly of Antarctica is in fact starting to flow out into the sea and is not allowed to hold it back.
Following publication of a new study, author Dr. Eric Renewable, writing in The Guardian, pointed out that while at the current rate of melt, the area might take 200 years to flow into the sea, evidence indicates the rate will continue to accelerate. Dr. Renewable pointed out that many similar glaciers in vast East Antarctica are less well studied. He wrote, "Just one of those, Totten Glacier, represents by itself a full 22 feet of sea level rise."
I usually let that one sink in just a little bit. So what the scientists are telling us is that if the Earth behaves the way it has for the last 4 billion years, over the next 100 years, our issue is that we're adding heat to the system more rapidly than it has ever happened under any natural scenario. There's been lots of times where carbon dioxide has changed, warming has changed, it's gone up and down, but it has always been a process that takes place over hundreds of thousands or even tens of millions of years. But we're doing it in a couple of hundred. And so we're stepping into territory that is unknown, but we do know that things have changed really fast in the past. And we don't know where we are on this continuum because we're running an experiment that's never been run before. This is the concern that we have about sea level rise. Now there are other concerns. Here's one that I usually like to throw out for more conservative audiences. Climate change is already costing you money. This is one of the things about climate change that's a little bit difficult is that it is a slow process, it's a gradual process, it's really diffuse, it's happening over the whole globe, so it's hard for us to get a handle on it. But I'm going to be going to Miami next week, assuming that it's still there after Hurricane Matthew gets through. In Miami, where sea level has risen now in the last maybe 100 years or so, something like 8 or 9 inches. And so the infrastructure that they have built historically is no longer quite up to the task. So they're finding themselves walking around with water up to their ankles every time there's a high tide. And next week will be the king tide, which is the highest tide of the year. So that will be interesting to see. But they're already spending $400 million on a pumping system that they hope will allow them to keep their real estate bubble going for another 10 or 20 years. because that's the gravy train that they're riding down in Miami. And we'll see. At the other end of the country in Kivalina, Alaska, this is a tiny Inuit community on the Arctic Ocean, and you can see how low and exposed they are to the water, which in the past has been much more likely to be dominated by ice, so there's not a whole lot of wave action, but now there's more open water, they're more exposed to the waves, and the water is higher. And so you can see they're building kind of a seawall around it here as a bit of a stopgap measure, but that's temporary. They know they're going to have to move. And the estimate is that that move will cost $100 million. There are hundreds of communities like Kivalina, and also many, many communities that are much larger than Kivalina. Do the math. Now, it's come home to some very conservative business people that this could be a problem. The insurance industry started warning us about climate change as far back as the 1970s. This is a chart from Munich Re, which is a company not many people have heard of, but it is a gigantic insurance company. In fact, it is an insurance company that insures insurance companies. Okay, so it's kind of like Lloyd's of London in that respect. And so they have been graphing out the monetary damages from natural catastrophes. This graph is from 1980 to 2010. And one of the objections to the argument that more disasters are happening is that, well, more disasters, it's costing more money because more people are building more houses in more vulnerable places, and so therefore just normal weather events are costing us more money. So what they did was they broke it out into earthquake, tidal wave, and volcano events, which are not influenced, as far as we know, by climate. And you can see that those damages are relatively flat. But when we look at storm, wind, and flood events, we see that they have gone up markedly. I think it's something like 300 plus 350% over this period of time. And that's in real dollars. So the insurance industry gets it, that this is happening. And in fact, today, this is what the weather map looks like in the Caribbean. Hurricane Matthew has maintained major hurricane, category 3 or above status for, well, it was 120 hours at like, 2 or 3 o'clock. Oh, 11 a.m. today. Okay, 11 a.m. today. So it has continued to be a gigantic hurricane. It's already impacting South Florida. We don't know if it's going to be a direct hit yet, but there's plenty of warm, abnormally warm, anomalously warm ocean water between the Bahamas, where it is now, and Florida and the East Coast, where it's heading. So stay tuned for that one. And it's an illustration. It is exactly the kind of thing that we expect to see as we have more interactions between the ordinary extreme weather events that we expect and a climate-enhanced world where there is more moisture, there is more warmth, there is more fuel for these events when they do happen to pick up and dump on us and become really, really powerful events, more so than what we've seen in the past. So this is my most recent Yale video, and I talked to a bunch of scientists here to try to help explain this connection between climate and weather, because it's not a one-to-one. You can't just point to a weather event and say, yes, that was a climate change event. Okay, so they're going to try to explain the more subtle ways that that climate is interacting with the ordinary weather that we've lived with for many thousands of years.
It's a very, very common question. Was this caused by climate change? I try to use these extreme events to educate the public on how to think about this.
This drought, which by a lot of different metrics is the worst drought in the history of California, and it's probably the worst drought in the last 1,000 years. It's the warm temperatures that are at least partially related to anthropogenic climate change, global warming, that are really have intensified this drought and made it much worse than it would have before.
Global warming doesn't cause drought, but it does intensify drought when it occurs. There's a bit of extra heat, a bit of extra energy available, so things dry out quicker, droughts develop a bit faster, more intense.
Kevin Trimberth, and in Carr's right. Climate has a handle on all of our weather.
The environment in which all events occur these days is different. And so, in fact, every storm is different. Every event is actually different. It has to be. The air being warmer means it can also hold more moisture. There's more moisture in the air, especially coming off of the oceans.
We haven't seen this level of rain in the low country in 1,000 years.
Intense rainfall events are increasing in many parts of the world, including most of the United States.
Making some places and some seasons wetter, while others become drier.
There has been a rather marked increase in the most extreme precipitation events.
An additional foot of rain is possible. In a warmer planet, evaporation happens faster. So when that storm comes along, as it always does, there's more water vapor sitting up there for that storm to pick up and dump on us.
The Met Office says it's been the worst period of rainfall in at least 248 years.
It's affecting our heavy precipitation events. And I don't say precipitation to be all sciencey, I say it because it's rain plus snow.
We've never seen this type of snow here in the city of Boston any other time in the history of our city.
If you look at the data here in Washington, D.C., we tended to see a trend towards less snow overall, but more big storms.
The trouble is that a lot of them look exactly like the ones that we've had in the past.
Natural variability hasn't gone away.
But when they're at the high end, then you start breaking records, and that's what we're seeing around the world, increasing numbers of broken records.
It actually rose 25 feet in 12 hours. That is the record flood stage. It actually was higher than that by about 4 feet.
And so I really need to look at this and say, is this within the normal range of variability, or is this outside of that?
It's also increasing the heat content of the ocean, and increasing the amount of energy available for hurricanes to soak up, converting from a tropical storm into category 4 or 5, even overnight if they pass over warm enough ocean water.
There is more energy available in the climate system that has to go somewhere, and so the weather systems have to respond to that.
So you expect to see more storms at the very high end, and there is evidence that indeed the frequency of the high end events are going up.
What is climate change doing to other weather extremes like tornadoes and windstorms and hail? The jury's still out on those questions.
With regard to storms, it's much more difficult to say, partly because the record is not as long or as reliable as we go back in time.
And with tornadoes, the climate record is poor because we don't have standard measurements of tornado strength going back. In terms of all the ducks lining up in a row, we only have a couple of ducks right now.
Imagine you have basketball players, only a handful at home if the dunk hits a 10-foot rim. Well, now we've raised the floor another foot, so now it's 9 feet. So now more and more basketball players can dunk. If you think of that dunk as water going up and over that seawall and inundating homes where people thought they were safe before, that's exactly what happened to St. Pete.
You know, we're not adequately prepared and weatherproofed for many of these things, even in the United States.
Because now storms that technically aren't major hurricanes are causing major hurricane damage.
You hit the nail on the head. This is not a big hurricane. This is a day at the office in Louisiana. And so as the ocean gets bigger and the sea surface gets warmer, you would expect more of these storms.
And so that's what we're worried about with Hurricane Matthew, frankly. When you saw the governor of South Carolina there talking about a 1,000-year weather event, she was talking about last year, Hurricane Joaquin came up the coast of the United States, did not make landfall, but the amount of moisture that it pushed ashore was enough to cause a 1,000-year rain event in the Carolinas. Massive, massive damage. So it, just like Scott Mandia said there, now storms that aren't even a major hurricane are causing major hurricane damage. That the rain event that we had in August in Louisiana was not a hurricane, it was a tropical depression, but it contained so much moisture. and dumped so much moisture. Had it been a hurricane, it would have been in the top 10 most damaging storms in history, right up with Sandy and Rita and Katrina. So storms that formerly would not have been major storms are becoming major storms because they're powered by climate change. So okay. And in case you think, well, we're not close to the ocean, we're here in Michigan where it's safe. Well, I have some bad news. Here was the headline in the Detroit Free Press just last week. Why do Detroit Metro's freeways keep flooding? And well, the answer is the Detroit freeways were built about 60 years ago, and the planet has changed since then. We are now getting more of these, the high-end precipitation events are now overwhelming infrastructure that was built for essentially another planet. So just 2 years ago, the same kind of thing happened in Detroit, and the freeways were shut down for several days at a time. We saw the same thing in Houston this spring. You're going to see these kind of pictures a lot because we're talking in this election a lot about infrastructure. Our infrastructure is not only aged and crumbling, it is inadequate because it's not built with a climate change world in mind. So we're going to pay for this. We're already paying now. It's already costing us money because it's shutting our cities down for days at a time, storms that 40 years ago would not have done so. And so we're either going to have to simply accept being shut down a certain amount of time every year, or we're going to have to build better infrastructure. Okay, it's a big part of this is still up to us and the choices that we make. I might as well say that I'm not one of the cottage industry of people online who say, you know, it's all done, the human race is over, you know, human extinction in our lifetime. What I tell people is, look, we're not getting off that easy. We're going to actually have to live with and deal with and work on and solve this problem, because we're going to be here and our kids are going to be here and our cities are going to be here, and it's coming at us right now. So we have to make choices, we have to make decisions, and we're going to have to spend some money. So heavy precipitation in the US has been going up dramatically. Again, not theory, measurement, rain gauges, pretty settled science, well understood technology. We see that it breaks down regionally. Especially if you are up in the Northeast, you're getting many more intense rain events, and we're right behind them here in the upper Midwest. Michigan's one of the places in the country that's getting hit with more and more of these intense precipitation events. And I see enough people with gray hair in here. You agree with me? We're seeing it. We're seeing it. People that are over 35 or 40 years old know that this is happening. We're seeing things that we don't remember seeing when we were kids. And it's happening worldwide. Again, these are measurements that are very straightforward and very hard to ignore. I'm just going to show you something dramatic here that my friend Catherine Hayhoe, you saw her in that previous video, put this together for the U.S. Global Change Research Group, and it talks about the kind of changes that we will probably see in Michigan depending on what we do and the choices that we make going forward. So here's the way she put it together. If we make the right choices and we're lucky, by mid-century, the climate in Michigan is going to look a little bit more like the climate in like Indiana. Okay. By the end of the century, we're going to look like a little bit more like maybe Missouri, kind of Arkansas climate. Okay? That's if we make the right decisions and things break our way. Now you notice here, she moved the little Michigan icon south to indicate warming, and she moved it a little bit west to indicate drying. Because paradoxically enough, although we are going to see more large precipitation events, the net result of large precipitation events is to dry out soil. Because we know what happens when you get that nice soaking rain that you fall asleep to and lasts all night, and it soaks into the soil and nourishes the soil and keeps everything in place, versus that intense 3 inches in 2 hours gully washer that washes the soil out into the lake, washes out pollution and pesticides, and is gone from the system, so dries out faster. And we're also seeing the snow retreat faster in the spring. So instead of having that blanket of nice moist snow through March that we used to have here in Michigan, now it's gone by sometimes end of January. Certainly by February it's starting to go away. And that means the soil is drying and drying out more by the time you get to June, July, August, and the heat waves start to really kick in. You don't have that residual moisture in the soil. So we're getting drier as we go forward. Now, if we don't make the right decisions, and we aren't lucky, by the middle of the century, what we might see in Michigan is that Missouri, Arkansas type of climate already. We're heading there. And if again, if we're unlucky and we don't make the right decisions, by the end of the century, Michigan's going to look a little bit like North Texas. So armadillos, brown recluse, you got it. Yeah, that's where we're headed. So now there's lots more bad news, but what I found after doing hundreds and hundreds of these presentations is that if you're going to describe a problem to people, you have to talk about the path forward. We got a problem. What are we going to do about it? There are solutions, and they're here. And we don't need any kind of scientific breakthrough. We don't need new technology. We don't need trillions of dollars in research. What we need is to deploy. We need to deploy the technologies that we already have. So I'm going to go through just a few of them, some of which you see right around us here in Michigan. One of my favorite places, the wind farm up in near Breckenridge, Michigan, extends across 2 counties there. There's several hundred turbines. It's extraordinary, it's beautiful, it's very successful. And it's part of an explosion of wind energy across the country that has just been, has taken a whole lot of experts completely by surprise. In fact, here was the headline in the New York Times not too long ago. Sun and wind are altering the global landscape and leaving utilities behind. Electric utility executives are watching as technologies they once dismissed are starting to threaten their business plans. Look for more of that. It's happening. So, for example, here in Michigan in 2009, 2010, when we were building our first big wind farms out in the Thumb, we were pleasantly surprised to find that the cost was about 10 cents a kilowatt hour for that electricity. Now, 10 cents a kilowatt hour that's about average for the cost of electricity across the United States. If you can generate electricity for 10 cents a kilowatt hour consistently, you will have a market, because that's pretty competitive. That's in a nice pocket for cost. Now, just 3 or 4 years later, the cost, the prices that were being cited for wind energy in Michigan had dropped by 50%. They were at 5 cents a kilowatt hour and dropping. And if you go to states where they have really extraordinary wind resources like the Dakotas, Montana, parts of Texas, the Great Plains, wind is now coming in at 2 and 3 cents a kilowatt hour, which literally beats everything. It just beats everything. It's completely blowing, literally blowing away a lot of the competition across the Great Plains, which led to one of my favorite headlines on my blog here: "Will gas break wind, or will wind pass gas?" The two technologies that are fighting it out for leadership in deployment are natural gas generators and wind power. Those are the kind of the big heavyweight hardware technologies that are at the top end right now, and they kind of they're jockeying for position. Sometimes gas is ahead, sometimes wind is ahead. Eventually wind is going to win because the prices keep coming down and the technology keeps getting better. Guess what? Mass production works, technology gets better. There are such things as learning curves, and they work. Yes?
I'm curious, have they solved the problem with birds?
There never was a problem with birds, and we can talk about that in Q&A, okay? Here's Texas. Now, Texas, this is the utility in San Antonio. Texas, if you've ever been out there in West Texas, it's an enormous, one of the most unpopulated, desolate areas in the country, and they have huge wind resource out there, and they've recently built some transmission lines that are starting to bring that wind into the populated cities more in the eastern part of Texas. And there's so much of that electricity coming in that there are times in Texas when there's actually, we have what we call negative pricing for electricity, because there's so much wind electricity that the utilities will literally pay you to take it off their hands. They say, please turn on your lights. In this case, in San Antonio, they have a nighttime special. If you can hold off on washing your dishes until after 9 o'clock, it's free. You know, if you can hold off if you're an industry and you can hold off on doing something in the off hours, you get either free or much reduced rates. And so we're starting to see that in places like Germany. Germany's had that for a long time. So this is good news, but it's also challenging news for utilities, because we're going to be having more and more of this essentially free fuel cost energy coming online, and it's really going to mess up their model. Now, the big gorilla corporation up where I live is Dow Chemical, huge chemical company, and they kind of surprised a lot of people. Didn't surprise me, but they surprised a lot of people last year when they bought a huge amount of wind to power their Freeport, Texas manufacturing plant, which is the largest plant of its kind in the Western Hemisphere, now powered entirely by wind. Okay? And trust me, I know, I've met the guys at Dow. They don't do things because it's politically correct or because it's touchy-feely. They're master bean counters. So if they're buying wind energy, it's because they're making more money by buying wind energy, okay? So be very, very clear on that. And you're seeing that across the country, across different industries. Right here locally, you have a company called Switch that when they wanted to build a multi-billion-dollar information center here locally, and the first question they asked was, can you get us 100% renewable power? And to their credit, Consumers Energy was able to arrange for them to be able to bring in enough wind energy so that they could power themselves 100% renewable. And you're going to see more and more corporations are adding that to their bottom line. They want to make sure that they are not creating more problems by using energy, because trust me, the people at the top end of corporations, even the big fossil fuel companies, Exxon, Chevron, Shell, BP, they get climate change. They know it's happening. They know they're going to have to deal with it. So this is 2 years ago. 43% of Fortune 500 companies and 60% of Fortune 100 companies have set climate or clean energy targets. Now, the next big story is solar. Solar is an absolutely monstrous story that we're starting to hear more about, but not nearly enough. People don't understand what is happening. It's an absolute game-changing, paradigm-shifting, deal-breaking revolution going on right now. And of course, there are people that don't like to hear about that. One of the countries that really pioneered wind energy, oddly enough, Germany, they were inspired by the United States. They were inspired by the renewable energy push under President Jimmy Carter that started in the 70s. They took it seriously and installed some policies in the last decade or two that have really pushed the implementation of wind and solar to a degree that is totally shocking people around the world. And here it's being discussed on Fox News. And so you're going to see a lot of Germany bashing, you know. I mean, how come Germany can do this and we can't? And so you're going to hear what the discussion is on Fox and Friends about this technological revolution.
What was Germany doing correct? Are they just a smaller country? They're a smaller country and they've got lots of sun, right? They've got a lot more sun than we do.
Well, there you go. They've got more sun. Okay. Thank you, Fox News. Okay, so as a public service, when I come to this part of the program, I realize we have not been to war with Germany in a long time. Many people don't know where it is. So a little geography lesson. Germany is a small, cloudy, cold, northern European country at about the same latitude as Labrador, Canada. Okay? Just to place yourself there. And if we look at this map of solar resources that's prepared by the National Renewable Energy Lab in the US, here's the United States solar resource. And as you can imagine, red means lots, yellow means yeah, kind of a lot, and green means pretty darn good. Blue and purple mean maybe not so much. Germany, completely blue and purple, as you can see. In fact, Germany, take a look down here, Germany gets less sun than Alaska. Okay, it has a poorer solar resource than Alaska, but they lead the world. Why is that? Why is that? Here's the cost curve for solar photovoltaics. These are those solar cells that when the sun shines on them, it creates electricity. Okay, this is where they were back in the 1977, $76 a watt, and now it's down, and this is 2013, 74 cents a watt, and it would get microscopic, but this curve continues to plummet. And this is why utilities, even the Wall Street Journal says utilities are facing a mortal threat from solar. It's going to break them. Now that's not necessarily a good thing. We got to think about that. This is a technology that is, we've seen this before, right? We saw what happened to newspapers when the internet came in. We saw what happened to landline phone companies when cell phones came in. And we're going to see it again as solar comes in to our utilities that are tied to this model of big generating plants, and then all of us on the outer rim are having to buy from this centralized power plant. And this model is blowing up all over the planet, okay? It is not sustainable. And we, unfortunately, in this state, in many states, we have politicians and we have powerful people who kind of like the way things were working last century, not so sure they like this century so much yet, and they're trying to kind of keep the power in the hands of those big centralized control organizations instead of spreading it out, which is what the technology wants to do, just like personal computers, just like cell phones. It wants to spread out, it wants to democratize, it wants to belong to everybody. And it's going to, because you can't put a lid on it. We've seen what happens. You can't put the internet back in a bag. But this is what we're going to have to do with it. This is the Financial Times. This is hardly a left-wing rag. Renewables, a rising power. Plunging prices, making solar competitive with conventional sources of energy. We're at the point where the demand starts to be driven by cold, hard economics rather than subsidies. That is a game changer. Going to hear those words a lot. Here's a solar farm in Colorado that beat out gas for a new utility power plant. We can now offer solar and wind that is cheaper than gas in some parts of the United States. That's happening now. And here's the Financial Times again. This is a remarkable article that came out this spring in thinking about the impact of the Paris Climate Agreement that was signed a year ago. The international objective agreed at the Paris climate talks implies, listen to this, listen to these words, Financial Times, implies the obsolescence of all fossil fuel production within the next few decades. Run that through your mind again. Obsolescence of all fossil fuel production within the next few decades. This is a technology that is absolutely turning the world as we know it upside down. This is making the internet revolution going to look like a small speed bump. Okay, and if we don't get ready for it with the right policies and with rebuilding our transmission system and turning our utilities into brokers of power, into people who distribute energy services rather than people who solely generate power, then our utilities are going to start, they're going to start circling the drain one by one. And I don't think Michigan can afford to have more of our flagship corporations on the ropes. We've seen what that looks like. It's not pretty. So we have to, the utilities operate at the pleasure of the democratically elected legislature and the citizens that elect them. We have to start sending them a message that it is time to look for the new technology and be ready for the new technology, because the states that are getting ready for it are the ones that are preparing to lead in the new century. And I think Michigan, we led in the last century. I think we should lead in this century too. I'm a Michigan boy, what can I say? So here's an example, Nevada. This was also this spring. I think this was the same week as that last article. Two of the biggest Las Vegas casino companies, MGM Resorts and Wynn, filed to leave the Nevada power system, and they want to buy wholesale utility on their own. They want to buy electricity from solar farms, from geothermal, and they want to generate their own because they think they can do it cheaper. So this is a big deal because MGM by itself, one company, is 5% of the demand of the whole Nevada power system. Okay, one company. And they were so eager to get off the system that they agreed to pay an $87 million exit fee. They said, we want out of here and we want it bad because we're going to save so much money, that $87 million bucks, we're not going to miss it. That's how big this deal is, and that's how fast it's moving, and it's coming here, folks. Sunny states first, yeah, but as the price drops, it's moving across the country. It's coming here. And it's already to the point where it's more a matter of policy than technology. The technology is there, okay? The policies, that's where we have a problem. Now here we are in this beautiful church, which I'm just finding stunning and inspiring. So I think it's appropriate to give some credit to Pope Francis, who really kind of woke up an awful lot of people who were asleep on the issue of climate change in the faith community. And many conservatives were kind of jolted when he came forward so strongly to talk about the need to deal with climate change, because climate change is not just an environmental issue, it's not just a political issue, it's not just a technological issue, it is a moral issue above all. Okay? And when we communicate it to people, if we can communicate in those moral terms about what is right and what is wrong, we're a lot more likely to convince and get them to understand than if we just deal with cold facts and tables, because most people just simply can't go there, they can't follow it. It doesn't resonate with them. In fact, we've got some polling on this. Americans are now starting to see climate change as a moral issue that obligates them to reduce carbon emissions. 2/3 of respondents in this Reuters poll said that world leaders are morally obligated to take action. And 70% said they were personally morally obligated to do what they can in their daily lives. So I want to finish with a video that I put together specifically on that moral imperative, and see if we can try to take this in and maybe when we leave here, go out and start framing that issue, especially during this election season, more in that way.
We can talk a lot about science, and you've heard a lot about that. We can talk a lot about economics, and these days all you hear is economics. But I think that the part of the debate that we have not heard enough about is the moral and ethical part. You know, what is our responsibility here? What is right and what is wrong? Because I think in the end, economic arguments, while powerful, aren't as strong as arguments about what's right.
Any change of climate is going to put stresses on a national, international community and tend to give rise to misunderstandings of geopolitical trends and others. And it's a destabilizing factor in the world. That's what worries me about the carbon dioxide issue.
Countries are being overrun by migrants, mostly Muslims.
A new study published yesterday finds climate change exacerbated the worst drought ever in modern Syria, aggravating social unrest in the country and helping to push it over the brink into civil war. According to Monday's report, the Syrian drought, worsened by climate change, was a key contributor in the ensuing 4 years of conflict. Conflict that has led to at least 210,000 deaths and forced more than 10 million people from their homes.
ExxonMobil, the largest of these companies, knew all the facts thoroughly as far back as 1977 and chose to put out false information or to support those who put out false information.
It really is the temperature that is helping to make this drought so severe. This drought has set a number of records along the way over at different times of the last 4 years.
California has approximately 1 year of water remaining in reservoir storage.
I don't think we can start away with science. I think we have to start with the values.
There's just a fundamental issue of morality that we were given this planet in a certain form, and I think it's our responsibility to leave options open for future generations.
It seems clear to me also that climate change is a problem we can no longer be left to a future generation.
They sort of stopped denying the science so much that basically we can't do anything against China, because China and India, China and India.
China's made an empty promise to do a little bit by 2030. I don't think that you're ever going to get third world countries to come around this. That is still running one coal plant per week. city is doing their damnedest to catch up with us.
China is set to announce a national carbon cap and trade system due to start in 2017. The plan would make China the world's largest carbon emissions market.
India has finally announced its plans in this 38-page document.
One of the country's main goals is to cut its carbon emission by 1/3 over the next 15 years.
What's the big deal about flowing water on Mars? Look at the temperature data that has been reported by NASA, has been made up, it's fraudulent for however many years. There isn't any warming, there hasn't been for 18.5 years. And yet they're lying about it. They're just making up the amount of ice in the North and South Poles, they're making up the temperatures, they're lying and making up false charts and so forth. So what's to stop them from making up something that happened on Mars?
You will struggle now to find climate deniers inside the oil industry. It's just become unacceptable. We recognise climate change. The next thing is we accept the fact the majority cause is man-made, a large part of it down to fossil fuels. There has to be a solution. And what that implies is the need for an energy transition.
Okay, so that's gonna wrap the formal part. We're gonna get into, I hope, some Q&A here, and I just want to thank Aaron for inviting me, and thank all you folks for coming out. I give many of these talks, and I just consider it my mission. And so I hope you'll check out the website. I hope you'll go to darksnow.org, consider possibly supporting that mission, and I hope that I'll see you again next time I come down to Grand Rapids. So I do like answering questions, and